Hello everyone, this lesson we're going to discuss in three-phase transformer connections. If you still remember on second year, we're talking about single-phase transformer connection, where parallel single-phase transformer together, we have to watch the polarity of the transformer terminals. If we don't watch the polarity, we get a wrong connection, we can have a short circuit happen. So same thing going to happen on three-phase transformer. If we didn't make the connection right, there's going to be short circuit with parallel transformer. To avoid that problem, CSA sets certain kind of standard to how to connect three-phase transformer together. So today we're going to discuss that standard. So CSA standard, they have a voltage phasor diagram set up to connect three-phase transformer. First thing is the requirement for phase displacement. The phase displacement is between the high voltage side and the low voltage side. For this example, the voltage between A to the neutral point on the high voltage side and the voltage between A and the neutral point on the low voltage side. If those two voltages it's not in phase, then we have a phase displacement. So the CSA standard is for Y to Y connection and the delta to delta connection, the phase displacement should be 0. For Y to delta or delta to Y connection, if we have an ABC phase rotation or ABC phase sequence, the high voltage side will lead the low voltage side by 30 degrees. So that's the CSA phase displacement requirement. Now we're going to look at those phasor diagrams. The first one is Y to Y connection. Delta to delta, Y to delta, delta to Y. We discuss each of them. The red letter here, A, B, C, is the line. So we connect high voltage side on the A, B, C 3 line down here. The low voltage side also we have A, B, C to indicating where the line going to connect to. The green letter A, B, C and the A, B, C here is each single phase transformer core or coil. So this portion is on the A phase on the high voltage side. This is going to be the A phase on the low voltage side. H1, H2, we're indicating this is the high voltage winding phasor diagram. X1, X2, we're indicating this is low voltage winding the phasor diagram. For here, this two phasor diagram is indicating the induced voltage. It's not the applied voltage. So here is the induced voltage on the secondary side, a low voltage side. Here is the induced voltage on the high voltage side. If this is the primary side, the induced voltage will be 180 degree difference with applied voltage. So, but for induced voltage on both high voltage side and the low voltage side, they should be in phase with each other. So you can see for this A phase, it came from this direction, goes that direction. The low voltage side, the same thing, X1, X2, going to the same direction and at the same angle here. Now we can discuss the CSA standard. This is a Y to Y connection. So A phase, H1 to H2, is at the 30 degree direction. On the low voltage side, on A phase, X1 and X2 is also at the 30 degree location. Same thing for B phase, C phase. For delta connection, delta to delta, line A, phase A is H1 to H2, that's a 60 degree direction, and the same on the low voltage side, A phase, X1, X2 is at the 60 degree direction. So we can see each phase, those in between Y and Y, delta and delta, for A to neutral, delta to delta, the center of this delta will be the neutral point, so it's also A to neutral, they are all at the same degree. So that's when the phase displacement is 0 degree. Now let's look at the Y delta and the delta Y. For Y delta, because my high voltage side Y is starting at A to neutral, H1 to H2 is at 30 degree, but this one on the delta side, X1, X2 is on phase A, is at the same 30 degree down here, but the neutral point for this delta is right in the center, so from A to the neutral point in the center is at 0 degree. That's why Y to delta, the high voltage side gonna lead this low voltage side by 30 degree. The special one is this delta Y. The delta starting at 60 degree, that's my phase A, H1 to H2. Phase A, X1 to X2 will be parallel to that H1 to H2. So this one is at 60 degree. If you're looking down here, for A to neutral point down here in the center is at 30 degree, but this A to neutral point is at 0 degree. So high voltage leads low voltage by 30 degree. The special thing here is for phase A transformer, my H1 is connected to A, H2 is connected to B. Low voltage side, phase A transformer, X1 is in the center of the neutral point, X2 is connected onto line B. So for delta to Y is something special. You can see the arrow for this Y is pointing out instead of all the Y connection, the arrow is pointing in. Putting in summary, we gave you some easy way to connect them. If you remember this, for Y to Y, delta to delta, or Y to delta, the transformer's low voltage winding terminal, X1, is connected to the same line as the high voltage winding terminal H1 connected. So this one here, X1 terminal connect to line A, H1 terminal connect to line A. This one, X1 terminal connect to line A, H1 terminal connect to line A. This one, X1 terminal connect to line A, H1 terminal also connect to the line A. The delta to Y, the transformer's low voltage winding terminal X2 connect to the same line as the high voltage winding terminal H2 connect to. So this delta Y is special. For phase A, H2 is connected to line B. Here, X2 is connected onto line B. Phase B, X2 connects on line C, same as B transformer, H2 connect to line C. So if you remember those simple rules, it will show you how to draw those phasor diagram and how to connect three-phase transformer. If you have a question, you can connect us online, send us an email.